All right, days 4 and 5, proving triangles similar. We're going to learn 3 ways to prove similarity. So earlier this semester, we learned 5 ways to prove triangles congruent. What does it mean to be congruent? Well, congruent, sides were equal and angles were equal. Okay? What were the 5 ways? ASA, SSS, SAS, AAS, and HL. Now we're going to learn 3 ways to prove similarity. What does it mean to be similar? Okay? Well, similar means angles are equal, the same, and sides are proportional. All right. Remember how we said there was no AA congruency because we can have a bigger and smaller version? Well, here we go. We do have an angle-angle similarity postulate. If 2 angles of one triangle are congruent to 2 angles of another triangle, the triangles are similar. Why is that? Well, let's just say that this was 40, and this was 40. And let's say this was 30, and this was 30. Let's make it 60. Okay? That would mean there's 80 left here, and there's 80 left here. So all 3 angles are the same. Okay? You only need 2 of them because the third one has to be the same. So if you have 2 that are the same, that means one triangle is a smaller or bigger version of the other one. So in this case, RST, and remember, follow the rules. No angle, number 2, number 1. No angle, number 2, number 1. Triangle LPM. Simple enough. Okay, side, side, side. So, before side, side, side was if they were the same, we had congruency. Well, now, if they're all proportional, then we have similarity. So, remember, if we're looking at 9 compared to 3, and 27 compared to 9, and 15 compared to 5, hopefully you can see that the big triangle is just 3 times, sorry, let's get 5 down here, that the big triangle is literally just 5 times 3, 9 times 3, and 3 times 3. But remember, you can just do division. And if you do 9 divided by 3, you get 3, and 3, and 3. And if you did the other direction, 3 divided by 9, 5 divided by 15, 9 divided by 27, if you put the small one on top, well, then you would have gotten 0.3 repeating, 0.3 repeating, 0.3 repeating, and if all the decimals are the same, we're good to go. So BIG is going to be RAM. This is a smaller version. And what's the scale factor? Well, depending on which way you're going, if you're going small to big, it's 1 over 3. If you're going big to small, it would be 3 over 1. Okay, side, angle, side. Now remember, we had a side, angle, side for congruence. Where the sides were the same and the angle was the same included, we had congruence. Well, now we're talking about proportion. So if these 2 are proportional the same way, so 5 over 10 and 3 over 6, well, if you divide those, what do you get? 0.5, 0.5. They're both proportional, and our angles, included angle matches, we have similarity. So SAW is congruent to MIH. And what's the scale factor? Again, depending on which way you're going, 1 to 2 or 2 to 1. Depends on which one you're starting with. Okay, are these similar? If so, by which way? Which rule? So, I have an included angle, they're both 90. So I'm looking for SAS as a possibility. So I have to compare 24 over 6 and 20 over 5. And I told you before, I like to put word labels, so like maybe big and small, keep it straight what I'm filling in where. And again, I can cross multiply and do 6 times 20 or 5 times 24, or I can just divide. And I get 4 for both, therefore I have a proportion. And if I would have done the small ones on top, I would have gotten 0.25. So they are similar by SAS similarity. MLN is similar to SPR. And the scale factor is 4 over 1 or 1 over 4, depending on the direction. Another example. Notice I have no angles marked, so I'm looking at side, 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 obviously. So, since it's laid out, I'm looking at 4 and 12, 5.5 and 30, and 10 and 6.5. So I'm going to do the work down here where it says. So I have 4 over 12. I have 5.5 over 30. And I have 10 over 16.5. I'm just going to do a quick division here. So 4 divided by 12 is 0.3 repeating. 5.5 divided by 30 is 0.183 repeating. And 10 divided by 16.5 is 0.60 repeating. That's a 0, it's just not showing up. Okay, so the answer is no. They are not similar because the ratios are not the same. Okay? All right, now look, notice this one. You might want to turn something around. It's hard to do this way for some people. So I'm going to redraw this big one over here. It's going to be smaller. But I'm going to try to draw it kind of the same way. And put the 58 up here. So 58 was L. Okay? And the 28 was opposite the 58. So I'll put the 28 here. Now, you got to kind of realize if I spin this, G is going to be here and U is going to be here. So UL is 20. All right? So now I got to compare. Now notice, I don't have two angles, so A is out. I don't have 3 sides, I only have 2 sides on each, so SSS is out. So I'm looking at SAS. Well, I have side, angle, side here, but I do not have side, angle, side over here. I would need an angle right there to be able to do this. I would need the 58 to be there, and it's not. So therefore, I cannot prove it. It's no. All right, are they similar? If so, by which way? Okay, well, notice I have parallel lines here. Okay? So since I have parallel lines, and if you want to kind of think about it, since we've kind of done this in the past this way, I have alternate interior angles are equal to each other. So this is equal to this, and the two obtuse are also equal. So we kind of think about that, and these lines here are transversals, all right? And these are my parallel lines. You kind of tilt your head and look at it that way. Then I know that this angle here is equal to this angle there. I also know I have vertical angles right here. Therefore, yes, by A similarity. There's no math to do, it's just two angles are the same. We have A similarity. So GET now think about it. I'm going from no angle to 2 to 1. So that means I have to do MEO. Keep the order correct. And the scale factor, we don't know because we don't have any sides. Okay, are they similar? If so, by which way? State the similarity statement and scale factor if you can. So the measures of side ABC are 4, 5, and 7. So we're just going to make a triangle. We're going to call it A, B, C. And we're just going to go in order, and it says 4, 5, 7. And then X, Y, Z, don't have to make it look bigger. I'm going to go in the same order, and it says 16, 20, 28. So, look at the drawings and see what lines up. 4 and 16 times 4. 5 and 20 times 4. 7 and 28 times 4. I don't even have to do the fractions. I can see it right there. Now, if you want to, you can. 4 over 16, 5 over 20, and 7 over 28. And you'll get 0.25, 0.25, 0.25. So it's yes by side, side, side similarity. And ABC is similar to X, Y, Z. And the scale factor, again, is 1 to 4, or 4 to 1, depending on your direction. Okay, what do we have here? Well, we have numbers for two sides, and we also have vertical angles here. So we're looking at SAS. Now, we don't know how they line up because we don't have any parallel lines. So we need to see, is this one and this one work out? So let's try it. 18 over 24 and 12 over 36. Well, if we divide those, 18 divided by 24 is 0.75. And 12 divided by 36 is 0.3 repeating. But don't be too quick to say, no, it doesn't work. We can go back and try, what about 12 to 24 and 18 and 36? So 12 over 24, 18 over 36, we get 0.5, 0.5, that works. So we do have yes, and we have SAS similarity. Now you have to be careful here. V, Y, Z. So we're starting in the middle. We're going to start in the middle on this one too. Now, we're going to Y. That's towards the 12. So we want to go towards the side on the other one that's proportional, so that's going to be the 24. So that's going to be V, W, X. And the scale factor, being 0.5, is 1 over 2, or if you went the other direction, it would be 2 over 1. And last but not least, kind of a quick summary. For congruency, we use this symbol. For similar, we use this. The theorems we already listed at the beginning, and the definitions we already listed on the first page. I'm not going to have you write them again. Just see page 1 of notes. And that's it.